Alright, crazy face, let's talk about 1 over x. What is happening? Well, things are happening. Let's maybe just try and plug some points in and see what's going on. How about an x value of 1? Well, 1 over 1, bloop, cool. Okay, how about an x value of 2? 1 over 2, alright. What about 3? 1 over 3? Okay, kind of harder to draw that accurately. 1 over 4? 1 over 5? What about if our x value was, say, like 10 bajillion? Well, it would be 1 over 10 bajillion, which is really, 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 really close to 0. These numbers are getting closer and 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 closer to 0 as x increases. Now, that's creating a horizontal asymptote on this graph. Okay, that's neat. So this part of the graph over here is all like, hi, I'm really low, and then I start to curve up. But then what happens? We have that point 1, 1, but what happens between 1 and 0? Let's do the same thing. Let's check some numbers. And I'm going to write this down to help you this time. What if we're at the x value of 1/2? Well, 1 over 1/2 is gross, fraction and a fraction. Let's rewrite that as 1 times the reciprocal of 1/2, 2 over 1. Well, I wrote 2 over 2. Let's go 2 over 1. So I have 1 times 2, right? Because dividing by a fraction is the same as multiplying by that fraction's reciprocal. Flip that fraction. 1 times 2. And so I have a point at x is 1/2 and y is 2. Interesting. 1/2, comma, 2. Okay, well, what if my x value was, say, 1/5? Well, then I would get 1 over 1/5, which becomes 1 times 5/1, which is just 5. And so, as I'm at 1/5, I'm up at 5. So think about what's happening here as I get closer and closer and closer and closer and closer to an x value of 0. My y value is getting crazy big. That is one way to think about this graph approaching a vertical asymptote at the x value of 0. Now think about why we have a vertical asymptote there. We have a vertical asymptote at the x value of 0 because if you plug 0 into this function, you get a 0 in the denominator of fraction, which math says, I cannot do that, and we get an asymptote. We got a hole in that last one because we had the x in the bottom and in the top. We get an asymptote here because the x is only in the bottom. Okay, well, that's certainly something to think more on, but what else? Is that all our graph looks like? No, because we can plug in negative numbers too. And it's going to be the exact same thing. All these negative numbers is going to be a perfect mirror image of that upper positive branch there, but down in negative land. 1 over negative 1 is negative 1. 1 over negative 2 is negative 1/2. 1 over negative 3 is negative 1/3, negative 1/4, negative 1/5. Again, notice I'm getting closer and closer and closer to 0, this time from the bottom. And as I move closer and closer and closer to right, moving left from right, closer to 0, well, what's going to happen? Well, at negative 1/2, I'm going to be at negative 2. At negative 1/3, I'm going to be at negative 3. At negative 1/5, I'm going to be at negative 5. So it's that same asymptotic behavior, this time in negative land. And again, look, it's like a perfect mirror image, kind of like flipped across that line. That's kind of crazy. But there you have it. Let's talk about our friend domain. Domain, x values, anything but 0. So x is an element of R such that x is not equal to 0. Kinda like abs x over x. Okay, so again, that means x is going to be an element of the interval from negative infinity up to, but not including 0, and then from 0, not including it, up to positive infinity. Range is going to be the exact same thing. Y in the set of real numbers such that y is not equal to 0. And then, additionally, same thing, y in the interval negative infinity up to 0, not including it, union with the set starting at 0 but not including it up to positive infinity. There you be. That is our reciprocal function.